Hello everyone and welcome to the video on balancing equations. I've got a really good technique to show you today. It's the technique that I learnt when I was doing my GCSEs and I found it really useful, so I'm going to share that with you. To start with, I've just got a really basic equation. It's just the formation of water from hydrogen and oxygen. So the first thing that we need to do here is we put a little dotted line down the middle of the equation arrow, and then on either side we need to write out each of the elements present. So we've got hydrogen and we've got oxygen. Hydrogen, oxygen, hydrogen, oxygen. Okay, so that needs to be on both sides, both on the reactant side and the product side. Next step, we need to count up the amount of atoms of each element on either side of the arrow. So here we've got 2 hydrogens and we've got 2 oxygens. On this side we've got 2 hydrogens, but we only have 1 oxygen. Okay, now if we take a look, we can see 2 hydrogens on both sides of the arrow, but here we've got 2 oxygens and we've got 1 oxygen there. So what we need to do is we need to add a 2 here, because if you look, if we add a 2 there, then we'll get 2 oxygens. So we can scribble this out here and rewrite 2, because we've got 2 lots of oxygen. We've now got 2 lots of 2 hydrogens, so that becomes 4. Okay, now let's go back to this side. 2 oxygens, perfect. But here we've got 2 hydrogens and 4 hydrogens there. So what we need to do on this side is say, okay, right, well, we can add a 2 there, scribble that out. We've got 2 lots of 2 hydrogens, so that gives you 4. Now let's take a look again. 4 lots of hydrogen, 4 lots of hydrogen, tick. 2 lots of oxygen, 2 lots of oxygen, tick. That's done. The next equation I'm going to show you isn't as easy as the water example, but the same principle applies. So the first step, we draw our dotted line. The next step, we count up the number of atoms of each element present on either side. Two lots of carbon, 6 lots of hydrogen, 2 lots of oxygen. 1 lot of carbon, 3 lots of oxygen, and 2 lots of hydrogen. You might have noticed that I've written out CHO on each side, and this order is super important because it means that this is the easiest way of balancing the equation. If you balance carbon first, then hydrogen, and then do the oxygens last. So let's do that. Okay, so on this side we've got 2 carbon atoms, but on this side we've got 1 carbon atom. So the only product that's got carbon in it is carbon dioxide. If we have a look here, we can just add a 2 in front of the carbon dioxide, so that gives us 2 lots of carbon dioxide. And then in terms of atoms, it gives us 2 atoms of carbon and 2 times 2 lots of oxygen. That makes 4, plus don't forget about the 1 oxygen we've got here, so that gives us 5. Okay, carbon is sorted. Now let's look at hydrogen. On this side, we've got 6 hydrogens, and on this side, we only have 2. So what we can do is add a 3 in front of the water, and that will give us 2 lots of 3, that will give us 6. 2 lots of 3 will give us 6. Okay, but we now need to take into account that we've got 3 more oxygens. So we've got 3 lots of oxygen, that's 3, plus the 4 we have from the carbon dioxide, that gives us 7. So this is where it gets tricky, because you can't have half a molecule of oxygen. Oxygen, if you draw it out, looks like that. And you can't have half a molecule of oxygen just to get the 1 atom. You can't have that. You can't break that in half just to get 1 oxygen. That's not possible. So what you can do at this point is put 3.5 here. Okay, because if we have 3.5 times 2, that gives us 7. But like we said, we can't have half an oxygen atom. But what we can do is times everything by 2 on both sides, because that will get rid of the half. So we've got 2 here, 7 here, 4 here, and 6 here. And if we take a look, two lots of ethane, 7 lots of oxygen, 4 lots of carbon dioxide, and 6 lots of water. It is quite scribbly and you will make quite a mess on your exam paper or your practice questions, but at the end of the day, this method really does work every time. It is pretty much foolproof. You can't mess it up as long as you follow the simple instructions. The last example I'm going to show you today is iron plus oxygen goes to iron 3 oxide. This one you have to think about because it might not be obvious at first, but again, using this method, we'll work it out. So iron, oxygen, iron, oxygen. Okay, let's take a look. 1 atom of iron, 2 atoms of oxygen, 2 atoms of iron, 3 atoms of oxygen. Now, in this instance, and again, this is something that you will learn as you practice these questions, but as you can see, iron is on its own, whereas oxygen, like I said earlier, is in this double bond with another oxygen atom. So it would be easiest to leave iron till last and do oxygen first. So let's balance oxygen first. So there's 2 oxygens on this side and 3 oxygens on this side. If you take a look, there's no simple way to balance this because obviously 2 doesn't go into 3 and 3 doesn't go into 2 to get a whole number. The lowest common multiple of 2 and 3 is 6. So if we intend on putting 6 atoms of oxygen on either side of the equation, what we can do is times this side by 2 and this side by 3 in terms of oxygen. So to times this by 2, times the amount of oxygen by 2, we just put a 2 there. Yep, 2 times 3 does give us 6, and 2 times 2, that gives us 4 lots of iron. Okay, and then on this side, we need to times it by 3, times the oxygen by 3. So we can pop a 3 in front of the oxygen there. 3 times 2, that gives us 6. And that's the tricky part over. 6 and 6 oxygen, tick. We're balanced either side. But then we've got 4 irons on this side and 1 iron on that side. So let's take a look. We can just put a 4 there, and then that gives us 4 lots of iron, 4 lots of iron, tick, we're all balanced. I hope you found this video useful. For more practice questions and for more GCSE, A-level, university, pre-GCSE content, go to harperium.com. There are plenty more free practice exam questions for GCSE, including balancing equations with the answers, all for free. I look forward to seeing you there. Thank you.